We know all about the internal components. What we're going to do is discuss the different measurements that are involved with a bunch of these, and this is going to help you make those better assessments when you're out buying different computer components as well as different software. So let's take a closer look. Now the CPU, or the brain of the computer, the central processing unit, this one is measured in how many operations can it do per second. Right? So how many additions, for example, can it do per second? We call this measurement frequency. Now typically a CPU, we see it measured in hertz. In the 90s, when I was in high school, my CPU ran at approximately 66 megahertz. And now that's if I pushed that awesome turbo button. If I didn't hit the turbo button, then it was running at 33 megahertz. Now you may say, well, so what? Well, today typically computers are running with a CPU speed of about 2.8 gigahertz. Now let's put some math in that. 1 gigahertz is approximately 1,000 megahertz. Now I used to be running at 66 megahertz. Now look at this. Now you're running at 2,800 megahertz. That's a lot. That's about 42 times faster than it was in only a few short years. I say a few short years because I'm trying to downplay how old I am. Either way. So what we're looking at here is a measurement that has expanded in a massive sense in a very short time frame. So 2.8 gigahertz, or when we look at this, 1 gigahertz is approximately equivalent to 1 billion operations per second. So a 1 gigahertz computer can do 1 billion additions per second. That's a lot. So a 2.8 gigahertz computer can do 2.8 billion operations per second. Interestingly enough, computers have evolved over the years to actually have more than one CPU in them at a time. So we have when this occurs, we say each CPU is called a core. So you might have a multi-core CPU, and oftentimes you might have a dual core, which means 2 cores, or a quad core, which means 4 cores. There's also some computers you can get them up to about 8 cores on consumer units. When I was in university, one of my professors in my parallel programming class, and this was back in 2003, he was running on a 16-core processor. That's insane, considering that was, from the time I'm making this video right now, approximately 13 years ago. That's a long time, and he had 16 cores then. So you can imagine how expensive that computer was back then. Now that course's full purpose was being able to program for multiple cores at a single time. And that takes some pretty inventive programming and some clever thinking. In any case, to do some math behind this, when we have multiple cores, we're basically just multiplying our speed, because each core has that speed. So for example, if you have a computer, a quad core computer that runs at 2.8 gigahertz, that means you have 4 cores, each running at 2.8 gigahertz, or together 11.2 gigahertz, or 11.2 billion operations per second. Now this is true on paper. In reality, it's going to be less, because there is some loss in speed, because there's just things traveling back and forth between the CPUs and whatnot, communication that occurs. So you don't actually get that number, but for argument's sake, yeah, that's about right. So then we get into the idea of memory. Now we talked about the smallest form of memory is a single bit, a 1 or a 0. But there's different units of measure. Just like if we have units of measure of distance. So for example, our smallest unit of measure that we typically talk about is a millimeter. All right? 10 millimeters make 1 centimeter. 100 centimeters make a meter. 1,000 meters make a kilometer, and so on and so forth. In memory terms, we start at a bit and we work our way up. Well, why do we care about this information? Well, depending on the software you're going to use, it's going to require more memory and sometimes more hard drive space. So for example, a video game may take gigabytes of memory to work all at one time because of all the images and videos and stuff that are going on. Whereas a simple program like Notepad will only take a couple bytes or kilobytes to operate. So it depends on the software you're going to be using. Whenever you go buy a new program, if you look at the side of the box, or if you're buying it online, there's always a system requirements section, and it tells you exactly how much RAM and hard drive space is required or recommended. So it might say you require at least 1 gigabyte of RAM and maybe 5 gigabytes of hard drive space. So you got to make sure that the components that you're buying, the RAM and the hard drive, are capable of handling that. So you got to keep that in mind when you're building your computer. So one day you're going to be going off to school, college, university, or whatever, and you're going to buy a new computer, and you got to think to yourself, well, what software am I going to be using on this computer in school? And you got to make sure the components you buy can satisfy the needs of that software. So let's look at the hierarchy of the different memory units that we're going to deal with. So a typical computer nowadays has about 1 terabyte of storage space in the hard drive, which is quite a bit. Now let's look at this math here. The smallest form of measure we said is a single bit, a 1 or a 0. If we have 8 bits, that's called a byte. Now from here on, everything is going to be a factor of 1024. So 1024 bytes is 1 kilobyte. 1024 kilobytes is 1 megabyte. 1024 megabytes is 1 gigabyte. 1024 gigabytes is 1 terabyte. And there are many, many more units after this: petabyte, xenobyte, and zettabyte, and all these other ones that I can't remember or pronounce for the most part. But we're going to, for all intents and purposes, we're going to stop at terabyte for now. It's going to be a little while before we pass that point on our standard hard drive spaces. Not to say we won't, because I'm sure we will. So anyways, now that we know this, we should be able to convert back and forth between these, just like we do in standard distance measurements. So for example, if I ask you how many millimeters are in 2.5 centimeters, well, you know that there's 10 millimeters per centimeter. So 10 times 2.5 is going to be 25 millimeters. We can do the exact same thing here. If I have 25 millimeters, I could say that there's 2.5 centimeters. We can do the same back and forth measurement here. So for example, whenever I have a larger unit of measure and I'm going to a smaller unit of measure, I'm going to have more of that smaller unit of measure. So I multiply. However, when I'm going the opposite direction, if I'm starting at a smaller unit of measure and going to a bigger unit of measure, I'm going to have less of those bigger units. So I divide. And how much do you multiply or divide by? Well, that just matters between which ones you're going. If you're going between bytes, kilobytes, or anything like that, you're always going to be multiplying by a factor of 1024. However, if you're ever going from bytes to bits or bits to bytes, it's going to be by a factor of 8 because of this unit right here, 8 bits in a byte. So let's look at some examples. So converting between data sizes is as simple as converting between any two forms of measurement. So if I say how many millimeters are in 2.7 meters, we just could do some math. We got to figure out, we got to go step by step. So for example, we're going to go from millimeters to centimeters and then from centimeters to meters. It's not just a one-step process. We actually have to go through this. So we know that there's 100 centimeters in a single millimeter. So that means 2.7 times 100 is going to give us 2,700 centimeters. Now, for some reason, that should be, we got to go one more step here. And that is going to give us, we got to multiply by 10 now because there's 10 millimeters in 1 centimeter. So that means that we have 10 times 2,700, or 27,000 millimeters in 2.7 meters. So it's not a single step process. We have to step through it one piece at a time. So let's try it with a little bit bigger. So how many bits are in a 4 gigabyte flash drive? Well, we start at gigabytes, and we're going to use this table right here. So we're going to start at gigabytes, and we're going to go one step at a time to a smaller unit of measure. And every time we're going to have to multiply because we're going from a bigger unit to a smaller unit. We're going to get more of them. So how many bits are in 4 gigabytes? So we start at 4 gigabytes, and from gigabytes we got to go to megabytes. So from gigabytes to megabytes, we're going to multiply by 1024, and we're going to get a value of 4096. Now we got to go from megabytes to kilobytes. So we're going to multiply 4096 by 1024. So now we're at 4,194,304 kilobytes. And now we got to go from kilobytes to bytes, and we got to do the operation again by 1024. So now we're at a value of 4,294,967,296 bytes. But how many bytes are in a bit? Or sorry, how many bits are in a byte? 8. So now when we do our multiplying, we're only going to multiply this number by 8 instead of 1024. So we end up with a value of 34,359,738,368 bits. That's how many ones and zeros are on a 4 gigabyte flash drive. 34 billion. That's a lot. And that's a small flash drive. 4 gigabytes is tiny by today's standards. Most people are walking around with 32, 64, 128 gigabyte flash drives. It's a lot. So that's obviously we can go the other direction as well. So if I wanted to, I could start at a large number of bits and say how many megabytes are in this bit or whatever. So depending on the math in the question, it may say just ignore any decimals when you end off or whatnot. Now, if we're going the opposite direction, we're going to be dividing. So you may actually end up with decimals depending on what goes on here. So you might have like 4.2 megabytes or something like that. So that's how we're going to do our conversions. So we talked about frequency, we talked about memory sizes and whatnot, and why you're doing this. When we look at that software, we look at the hardware and say, what are the requirements we actually need? So the next video, we're going to start talking about the external components of a computer.